We're basically being asked to solve simultaneous equations in this question, and in fact, the left-hand curve looks a little bit like this. It's called a hyperbola. It's a little bit like your 1 over x, and then this curve on the right is actually a straight line. And what we are doing is finding where these two graphs intersect, and where they intersect, the x and y values are the same. So we can substitute in either for x or y. Now, for me, it makes sense because I've got a 2y. Let's just make x the subject and substitute in for that, but you don't have to. You could have made y the subject and then substituted it in, especially because it only occurs once here. I might look at that at the end, but I'm going to go with x. It just seems to be the one to go with. So now I can replace all my x's by 4 minus 2y, and this is what my second line will look like. 3, 4 minus 2y, y plus 4 minus 2y squared plus 14 equals 0. And we've constructed essentially a quadratic in just one of the unknowns. Yes, there's still quite a lot to do. We can't solve it straight from here, but we're well on our way. Okay, I'm going to rewrite it as 3y 4 minus 2y. I have to remember to multiply through by both of these. I'm going to do it in one go. And this one is going to be a double bracket. Okay, so next step is that it will become 12y minus 6y squared plus 16 minus 8y, so minus 16y plus 4y squared plus 14 equals 0. Combine the y squareds, we're going to get minus 2y squared. Combine the y's, we're going to get minus 4y. Let's just underline the ones we've dealt with. This one, this one, this one, this one. Then it's going to become plus 30 equals 0. Now if I divide through by minus 2, that will make the coefficient of y squared 1. And will give me this. You could alternatively imagine adding everything onto the other side and then dividing by 2, you'll get the same answer. This will factorize to y plus 5, y minus 3 equals 0. So y1 equals minus 5, y2 equals 3. And we haven't finished, we just need to substitute back in to here to get the x value. x1 is going to be, when we put minus 5 in, we're going to get 4 minus 2 times minus 5, that's going to be 4 plus 10, 14. And x2, when I substitute 3 in, I'm going to get 4 minus 6, I'm going to get minus 2. So final answers are going to be 14 minus 5, or minus 2, 3. Now let's just take a little look at if we had made y the subject of the first formula, because actually it works out quite nicely as well. It might not seem like it's going to, but it ends up doing that. So we could write down that 2y is equal to 4 minus x. And then, yeah, let's go for it. Y is equal to 2 minus, actually, let's write 4 minus x all over 2. So now we replace this y here by this here to give 3x 4 minus x over 2 plus x squared plus 14 equals 0. I'm going to multiply everything through by 2. That just seems a good idea. So it cancels from here. I've got 2x squared plus 28 equals 0, which gives 12x. Not really sure which method's better, but this one works just as well. Then I'm going to get minus x squared. I'm going to add it onto the other side. I'm going to minus 12x. I can sort of rearrange it to this. And then I need two numbers that multiply to give 28 and add to give minus 12. Oh yeah, I missed them for a second. It's going to become x minus 14, x plus 2 equals 0. And we've got our solutions again from before, 14 and minus 2, and you can get your y solutions as well. So yeah, this is similar amount. You don't have to expand the double bracket in this case. It's just you have to deal with this fraction. So maybe, arguably in this case, the second way is better. But just as long as you got it there, that's the main thing, and I hope you're happy with both methods.